Hi there, Expo Algebra. This is Mr. Monahan doing the 9.3 notes. Our objective today is to solve quadratic equations doing two things. One of them is going to be by graphing, and one of them is going to be by using square roots. So today we're going to talk about why we've been graphing or what that can be useful for, but then we're going to start to look at some other ways for us to solve these quadratics. So even this, we have not even really talked about what solving a quadratic means yet. So we'll talk about that, and then we will get you lots of practice with everything that we're asking you to do. Before we move any further, just a little bit of review of graphing. So this one says, match the equations to their graphs. Okay, that sounds simple enough. So we're looking at, we have four different graphs in front of us. I am going to look at which way some of these open first. So number one, x squared minus 4x plus 1, there's not a negative sign, so this one's going to open up. This one, number 3, is going to open up. And then I have a negative over here, which is going to open down. And then this one is going to open down. So just starting my process of elimination here. I know that number 1 and number 3 have to be either A or C because those are the ones that open up. And then I know 2 and 4 have to be B and D because those are the ones that open down. So let's try to figure out just with axis of symmetry if that's enough to figure out what we need. Remember, axis of symmetry is negative B over 2A. So let's try that for some of these. So number 1, B is negative 4. So negative B is like negative 4 over 2 times A, which there's no A in front, so you can always put a 1 in there if that happens. So I have 4 over 2, which is just going to be 2. So x equals 2 will be my axis of symmetry here for number 1. So that means when I'm looking at a graph, I'm looking at a vertical line going right down through the middle at x equals 2. So the vertex would be at 2 comma something. So it looks like this is going to have to be the number 1 graph. Okay? Because the other one that opens up does not have an axis of symmetry of 1. It has an axis of symmetry of, it looks like, negative 1 this time. So then that means I know that this one will have to be the number 3 graph, because what I'm looking at is that's the only other one that's going to open up. So I have those two. Now I need to look at the two that open down. So let's look at the axis of symmetry for number 2. It would be negative 8 over 2 times negative 2. Okay? Negative 8 up top is positive 8. 2 times negative 2 is negative 4. So x is going to equal negative 2 for this axis of symmetry. So I'm going to look for the one that's opening down where the axis of symmetry is x equals negative 2, and that's right here. So this would have to be my the graph that goes with number 2, and this would have to be the graph then that has to go with number 4. So just using what you know about axis of symmetry and opening up and down to try to use kind of a process of elimination on those. All right, so then we're looking at solving quadratics. Okay, first things first. What does solving a quadratic even mean? So what we're going to start to look for are something called the roots or the zeros of these quadratic equations, or the solutions. Another way to think about it is the X-Intercept, which is something that I'm going to talk with you about here very shortly. But what we're going to start to see when you're talking about solving these is you need your quadratics to be in standard form. Okay? What that means is they have to be equal to 0. So it might look like this. ax squared plus bx plus c equals 0. And sometimes there's not a b term. Sometimes there's not a c term. But we have to have the part where it says equal to 0. And there's going to be 4 ways that I'm going to talk to you about throughout this chapter about how to solve quadratics. We're going to cover 2 of them today. We're going to do graphing today because we've already been practicing that. and then we're going to do using square roots. Okay, graphing is honestly not the best way to solve these because it takes a little bit of time. And it's kind of a process, and it's not always the most efficient way to do things. But by the end of this chapter, you'll have all the best ways to do it, and you'll have to choose which one to use at which time. Okay? All right, so solving quadratics by graphing. Okay? When you are solving, you're looking for the zeros, which means you want to know what x inputs give me an output of 0. What numbers do I have to plug in for x in order for y to be 0? So here's something that's super important. This is what we're doing here. Okay, when you solve by graphing, solutions are the x-intercepts of the graph. Okay, I'm going to try to make that really important because I might even just ask you something like that on homework or other places. Okay, so when you're solving by graphing, you're looking at the picture and you're trying to say, all right, where does the red parabola cross the x-axis? Okay, these are the x-intercepts. So it looks like it's at 2 and -2. So for this graph that I'm looking at, the equation is here, x squared minus 4 equals 0. Okay, this is the graph of x squared minus 4 equals 0 right here. Okay, if you look at where the graph is crossing the blue line, the x-axis, these are the x-intercepts. So this is x equals -2, and this is x equals 2. Well, what's happening right there? These are the solutions. These are going to be like our answers. What's happening is if you plug those numbers in, you get out 0. So if you plug in -2 to x squared minus 4, you get -2 squared minus 4 equals 0. Well, that's 4 minus 4 equals 0, or 0 equals 0. So what's happening is we found one of the values of x that make the whole thing go to 0. And then the other one is if you plug in +2. 2 squared minus 4 equals 0. That's 4 minus 4, so 0 equals 0. So again, there's two different numbers I could have plugged in to get a 0 out, and I found what those were. So when you're solving quadratics, one thing that you can do is solve by graphing, and what you're looking for are the x-intercepts of the graph. Okay? There can be a couple of different varieties for your answer. Sometimes there's 2 solutions like we just saw. Sometimes there's only 1. Sometimes there's 0, okay, as far as how many solutions there can be. We will learn about non-real solutions in Algebra 2, but for this course, solutions is always just going to refer to real numbers, okay? But have this idea in your head. If you're solving quadratics, okay, what you're doing is finding the x-intercepts. Another word for that is roots. Another word for that is zeros. Okay. All right, let's move on. Okay, let's practice solving these by graphing. So it says, what are the solutions to each equation? Use a graph of the related function. So just remember how we graphed these. Okay, when it was not a complicated one, when it was not a complicated graph, okay, what we did is when I say not complicated, I mean no b term. What we did is we just made a little table. Okay, the vertex had to be at 0. If you plug in 0, you get out -1. Then we just plugged in numbers around that value. If you plug in 1, you get 1 minus 1, which is 0. So that should be the same as if you plug in -1. If you plug in 2, you get 4 minus 1, which is 3. So that would be the same as if you plugged in -2. You should get out 3. Okay, so then what we're looking at then, we have x squared minus 1 equal to 0. We're trying to graph that parabola to solve the equation. So I'm going to put the dots on that I just found. And what I'm interested in are the dots that I just made. We'll come back and talk about that in a second. What I'm interested in for these is where is the parabola crossing the x-axis, which is this one, remember? Okay, and that's happening in 2 different spots. I know my curve was a little bit off, but right here and right here. Okay, those are my solutions. Those are my x-intercepts. So one of them was here at plugging in 1. One of them was here plugging in -1. So the solutions are at 1. I'm going to write that a little bit better. X equals 1 and x equals -1. Those are my solutions. Okay. X squared equals 0. This is just the parent function. This is just what we started off with graphing. Okay. If you plug in 0, you get out 0. If you plug in 1 or -1, you get out 1. If you plug in 2 or -2, you get out 4. Okay, let's graph that. 0, 0, 1, 1, 1 negative, or -1, 1, 2, 4, and -2, 4. Okay, there's my parabola. Okay, this time the parabola is sitting right on top of the x-axis, which makes this the one and only solution. The solution to this one is at x equals 0. If you plug in 0, you get out 0. If you plug any other number in for x in this equation, you will get something that's non-zero. So the only way for this one to work is if x is 0. So this one had 2 solutions. The one that we just looked at had 1 solution. Let's look at this next one and see what else is possible. So x squared plus 1 equals 0. Let's make a chart for that. Put 0 in the middle. If you put in 0, you get out +1. If you put in 1, you get 1 plus 1. So same with -1. If you plug in 2, you get 4 plus 1, which is 5. Same with -2. Okay, let's plot that. At 0, we're at 1. At 1, we're at 2. At -1, we're at 2. At 2, we're at 1, 2, 3, 4, 5. And same over here. Here's my parabola. And then here's where we get something that's a little bit different. My solutions are whenever the red parabola crosses this blue x-axis. Well, that's not happening here. There's a gap. I have an increasing or a smiley face parabola, and it hasn't touched the blue line yet. But as you can see here, the red parabola is never going to get close enough to touch. This is the minimum right here, which means it's never going to get to the x-axis. There's no point where my red parabola is crossing that x-axis. So this is an example of a quadratic formula that has no real solutions. It doesn't cross the x-axis anywhere. There are 0 x-intercepts. Let's look at x squared minus 9 equals 0. So I know that for this one, there's going to be an x-intercept at -9. So that's like plugging in 0 again. Okay, so 0, you get -9. At 1 and -1, you get 1 minus 9, which is -8. If I plug in 2, then I'm going to get 4 minus 9, which is -5. I'm going to skip 1 here, and I'm going to go to 3. Look at what happens if you plug in 3 and -3. If you plug in 3, you get 9 minus 9, which is 0. If you plug in -3, you get 9 minus 9, which is 0. So those are going to be interesting, or the points that we care about right here and right here are going to be essentially our answers. What can I plug in for x that gets me out a 0? So let me show you the graph again. So 0, -9. At 1, we're at -8. And at -1, we're at -8. And then we're kind of skipping 2. I'm going right to 3, which is at 0, and -3, which is 0. You could have plugged in 2. It would have been, what did we say, -5. So 2, 1, 2, 3, 4, 5, and -2, 5. Okay. But what's happening here is we are crossing the x-axis in 2 different spots, right here and right here. So since the graph is crossing in 2 different spots, that means that there's 2 answers. One of them is at x equals -3. One of them is at x equals +3. So that's how you solve by graph. Okay. Number 5 is going to be another one with no real solutions. Here's how you can tell. this is going to be your y-intercept up at positive 6, 1, 2, 3, 4, 5, 6, and then it's going to open up from there, okay, since this is a positive number. This is going to be another one with no real solution. So that one I was kind of lazy on. I didn't go through the whole process of graphing, but I can tell it starts above the x-axis and it opens up. So it's never going to turn back and be able to touch this line. It's never going to be able to kind of bridge that gap right there. So that's how you solve by graphing. The thing with solving by graph so great is that it takes a lot of time. It takes time and it's easy to mess some of these things up. So we're going to go right into a new strategy of solving by square rooting. And this is something that if you can do this, you should always do this. Because what you want is, if you have the equation set up a certain way, you can solve by square roots, which is something that takes just a couple of seconds. Instead of graphing, making an entire table and finding the axis of symmetry and all those things. Okay? So solving by square rooting is the second way I'll show you of how to solve a quadratic. All right, to solve an equation using square roots, the equation must be able to be written as ax squared equal to c. Okay, where c again is just some number. Okay, in other words, there is something that's important here. Okay, the equation can't have a b term. Okay, that's going to be important. You can't have you can't solve something with a b term by square roots. All right, so here's going to kind of be your steps. So what you're going to do, so let's make up a pretend one here. So my equation is x squared minus 9 equals 0. So what we would want to be able to do is isolate the x squared on one side. What that would mean is I need to make it so that this x squared is the only thing on the left-hand side. So what that means is I would need to move this negative 9 over by adding 9 to both sides. So then I would be at x squared equals 9. Again, it has to be able to be written like this. Notice that this form matches this form. Okay? Then what you're going to do is you're going to take the square root of both sides. So what that means is you square root the x squared and you square root the 9. When you do this, something important has to happen. Okay, this is really important. Okay, when you square root something that's an equality, you need to include this symbol right here, which is called a plus or minus. Because really, this is something that has two solutions. If we were to look at the graph, it would have a solution at 3 and at negative 3. So when you add a square root in, what happens is right here, the square root of x squared, the square root sign and the little 2 right here are like opposites. They cancel each other out. So all we're left with is an x right here. But when you evaluate the square root on the right, you have to remember to add in a plus or a minus because, or really I should have added it almost right away in this step, okay? Because when you put a square root into an equation, you have to keep in mind that there's 2 ways to get 9 with the same number. You can do 3 times 3 or negative 3 times negative 3. So when you solve by square roots, you have to remember you're going to have 2 answers, okay? The plus or minus part is key. You got to remember that. Okay? After that, nothing's too difficult with it. So, an example of this one, it says, what are the solutions of each equation? Okay, notice how none of these have a b term. This would not work for x squared plus 10x minus 20 equals 0. You would not be able to solve that by square roots, okay? Because you have an extra x in there. So it has to be just an a term and a c term. Kind of back to that first day of graphing. All right, so I want to get this x squared to be all alone. Okay, I want that to be all that's on the left-hand side. So that means I need to move the 75 and the 3. Okay, I can't divide both sides by 3 yet because the 3x squared isn't the only thing on this side. If I see an addition or a subtraction, I need to do that first. Okay, that has to be the first thing that I look at here. So on the left, I'll get 3x squared. Over here, I have positive 75 now. Okay. Now, I'm trying to get this x squared to be all alone. So I need to get rid of the 3 by doing the opposite of multiply, which is divide. So I'm at 3 divided by 3 on this side cancels. 75 divided by 3 on this side is 25. I want to take the square root of both sides, and when I do that, okay, I really have to think about it as plus or minus, because over here I get x. The square root of 25 is 5, but I have to remember to include the plus or minus, because I could put 5 right here, or I could put negative 5 right here, and my answer will work out the same either way. Let's do that, actually. If I put 3 times 5 squared minus 75, that's supposed to give me 0. I get 25 times 3 right here, which is 75, and 75 minus 75 is 0. But it also works for negative 5, because if you do negative 5 in parentheses squared, you get 25 times 3 is 75, and 75 minus 75 will be 0 again. So you should be able to kind of check your work here. But we have plus or minus 5. Okay. All right, over here, the one that I want to get all alone is just the m squared. There's nothing in front of it this time. What I need to do is move the 36, the negative 36 over by adding both sides by 36. Then I'll have the m squared alone, just like I want it. Okay. When you take the square root of both sides, you have to remember to include the plus or minus symbol. Okay. The square root of 36 is 6, but we have answers of plus or minus 6 as potential solutions. If you plug 6 in here, you get 6 squared, which is 36 minus 36, which equals 0. Same if you plug in negative 6. Negative 6 times negative 6 is positive 36. 36 minus 36 is 0. Okay. Let's look at this one. It's a little bit different. Make sure you pay attention here. I want to get the x squared isolated. Okay. The first thing I want to do is move the 15 over. Okay. When I move the 15 over, that means I'm subtracting by 15, which is going to be a problem in a second, and I'll show you why. Okay. Now on here, I still don't have x squared as the only thing on this side, so I need to continue to move stuff away. I'm dividing by 3 here. Now x squared is all alone, which means I'm able to do the square root of both sides. Okay, I'm going to include the plus or minus on the right as well. Okay, but let me show you something. Let's go to the calculator here, and we'll punch this in and see what happens. Okay. We're looking for two numbers that multiply, or one number that when you multiply it by itself, you get negative 5. I don't know if you've ever tried to plug a negative square root in, but it doesn't work. It says error. Mine says non-real answers right there, if you can see that. Okay? When you take a square root of a negative number, it gives you an error in the calculator because you can't do that. You can't have the same number multiplied by itself be negative, right? If it was a negative number times itself, it would be positive. If it was a positive number times itself, it would be positive. There's no way to multiply the same thing by itself and get negative 5 or negative 10 or negative 4 or whatever it might be. So for this one, it's almost a trick question. Since this is a negative square root, you can't take the square root of a negative number without something that you'll learn in Algebra 2, which is called imaginary numbers. Okay, that's why it says it's a non-real answer. This does not have an answer. So if you're taking a square root of a negative, the answer is going to be no real solutions. There are some imaginary solutions, but you don't need to worry about that until Algebra 2. Okay? So the first two that we had two solutions, plus or minus 5, plus or minus 6. Those are two solutions each. This one had 0 solutions. If you think about what the graph would have looked like again, okay, this would have been our y-intercept, so it would have started way up here at 15, and it would have opened up, which means it never got to this line close enough to intersect it. So there should be no solutions. That should make some sense. Okay, there are no x-intercepts here. Okay, last one, let's get the d squared by itself, subtract both sides by 16, then you get 4d squared equals 0. You might think that that's a problem, but it's really not. Divide both sides by 4, 0 divided by 4 is 0, and the square root of 0, I'm going to include the plus or minus in there, but the square root of 0 is plus or minus 0, but there's not really a positive and negative side of 0, it's just 0. There's only one solution right here. Plus or minus 0 doesn't really make sense. There's no such thing as negative 0. Right? So that's how you can have one solution. The graph of that would look like this, where there's a dot right at 0, and then it's opening up from there. This one's opening up because there's a positive 4 up front. Okay? So what you're finding is the x-intercepts. This is just a way to find the x-intercepts without having to graph it. If you see this set up where you can solve by square roots, it's always a good idea. Okay? And that's it for today. So I'm going to let you go. Thanks for watching. Have a great day. Let your teacher know if you have questions on the assignment.